welcome to the very first episode of Forward Deployed. This is a podcast about the intersection of AI, software development, and the enterprise. I'm Noah Brier. I'm co-founder of Alephic, and my co-host here is Lance Martin. Lance, can you introduce yourself?
Yeah, Lance Martin. I'm one of the founding engineers at LangChain. And I've known Noah for many years, predating AI even, or this current generation of AI, but certainly we probably met in one of the AI winters.
Yeah, so you're sort of underselling yourself by just saying that you are one of the founding engineers at LangChain. Can you give a quick sort of 2-minute bio on you
Yeah.
and what you've been doing in this world for a while?
Yeah, well, my background, I tracked academic for a while. So I did a PhD at Stanford. I did a lot of work in actually computational bio and biophysics and genomics, but made my way from there actually to computer vision. Towards the end of my PhD, I took a class by a guy who's now become pretty famous named Andrej Karpathy. I'm sure some of you have heard of him. And he took a course on convolutional neural networks. This was early 2015. Took the course and got really interested in vision and went to Uber and was one of the leads on the self-driving program. So I was the self-driving vision lead for trucks. And then we spun a company out of there, sold that to Neuro. Then kind of in 2023, when AI, this wave of AI and LLMs was really hitting, I kind of moved from Neuro to LangChain. So my arc's kind of been applied AI for many years, working in computational bio, vision, autonomy, and now, so I've kind of seen the arc of AI through a few different kind of phases, but it's really been kind of one continuous kind of scaling, starting all the way back from kind of 2015 era convolution, or 2013, 2015 convolutional networks, deep learning to where we are today. So it's been really interesting to see that all play through.
I feel like if we put together a sort of patron saints of the world of forward deployed engineering, Karpathy belongs in there. For me, just as a hacker, I mean, I remember his post, The Unreasonable Effectiveness of RNNs. It's probably 2014 or something. And that was the first time I ever played around with it. It had a full set of instructions on just how to get your own recurrent neural network going on your Mac, and pretty stupid in the sort of compared to what we have today, but a pretty epic experience for the first time. See something pop out of your computer that wasn't programmed or trained. So, just by way of background, for me, I started my career in marketing. I taught myself to write code about 15 years ago now, a little more, and started my first software company in 2011. Started with James Gross. That's how we know each other. We sold that in 2019, did something else. And then in 2022, I was taking a break from having startups, having employees, having investors. And it was a good time because I got obsessed with AI. And you and I started texting a lot around then. I think I was trying to convince you that these were good enough as they were. And I haven't stopped being obsessed since then. So I just keep playing around and keep exploring. And now James and I got the band back together. We started Alephic in about a year ago now. So that's what we've been up to. And I think our hope, and I've been wanting to sort of figure out a fun project to do with you because I love talking about this stuff. My thought with this kind of forward deployed thing, and it's a big sort of term that's moving around the industry, but to me, it's just fundamentally about people who are applying, right? And, I think it's pretty kind of synonymous with AI engineering, but it's just, it's about the application of these tools. And it's about bringing them into real companies and real use cases. So that's what I'm pretty stoked about. And I think, but you and I can also just kind of nerd out, and that's what I'm looking forward to.
Yeah, on the theme of forward deployed, this Andreessen article came out. We'll obviously put it in the show notes, but I thought it was kind of interesting. And the point they made, which kind of resonates with a lot of what we've seen at LangChain, is during platform shifts in particular, there's a lot of opportunity for companies to kind of do things that are new. And LLMs are a new kind of fundamental kind of computing primitive. And kind of what we've seen from talking to companies is kind of on this forward deployed theme. Companies want like a partner to go on the AI journey. It's not like they want, oh, here's a product. It's like, no, we want to think about how we can use AI both internally to, for example, like automate internal processes, and also externally inject it into our products. So there's this kind of big thing happening across many companies. And this is why forward deployed engineers are becoming so kind of sought after. That's the whole take from this article, that like a forward deployed engineer is like the new hot job. And I do think it is the case that companies want people, they want partners for this AI journey, and forward deployed engineers we have a large set of forward deployed engineers at LangChain, and they do a lot of great work with our customers. And oftentimes it is really, these companies want a partner for like this AI journey, which is just starting. And I think that's kind of why it's an interesting new kind of term. It's obviously been around for a while through Palantir. They kind of pioneered the model, but with AI, because of this major platform shift, there's a lot of demand for this kind of like partner for the journey that many companies are seeking.
Yeah, and I think the other piece, I mean, we see it too. We have a whole team of forward deployed engineers at Alephic now. And, I think there's a whole theme here, which we don't get into it today. I'm sure we'll get into it at some point, which is just AI lets you sort of close the gap between people with problems and the people who can solve problems. And I think that's sort of what's really amazing.
Yeah.
I think, when I kind of look back at what we've done over the last year, I've come to kind of realize that we obviously work mostly with marketers, helping them kind of figure this stuff out. But the kind of big insight I had is a lot of what we're doing is we're bringing kind of software development practices into marketing organizations. And part of the reason they haven't had it and the real AI breakthrough and all that is that like AI enables you to solve a different class of problem, right? Because you don't have to have structured data for the first time. And so, the problems that were softwareable inside marketing organizations, and I think, again, marketing as a sort of proxy for every part of the organization, were very structured problems, right? In marketing, it was like ad tech and workflow. And now you're like, well, we can solve creative problems like copywriting or any of these different kinds of things. And this is just entirely new realms, right? This is also where coding tools and the ability to kind of write code and build with the AIs. I don't know. It's fun. It's interesting. I think it swings the power dynamic away from SaaS a little bit, starts to sort of give it back to the engineers. And I just think it's like just good. Like, to me, the whole forward thing is like, you're not back office engineers anymore. You're actually out and you're sitting with real people and real customers who have real problems. I think it's awesome. So if we take it in a different direction, I got here. I thought it'd be fun as a place to start, especially because I think you're the one who first sent me the bitter lesson back in the day. So Richard Sutton, father of reinforcement learning, was on the Dwarkesh podcast, and I thought this would be a fun place to talk because I also think the conversation that they had is a pretty good representation to me of the difference between sort of the conversation that is the academic one about AI, which is very interesting and very important, but very different than the kind of engineering forward deployed one. So I was just going to play this quick clip to kind of get us in the mood.
What is intelligence? The problem is to understand your world, and reinforcement learning is about understanding your world, whereas large language models are about mimicking people, doing what people say you should do, about figuring out what to do.
You would think that to emulate the trillions of tokens in the corpus of internet text, you would have to build a world model. In fact, these models do seem to have very robust world models, and they're the best world models we've made to date in AI, right? So what do you think that's missing?
I would disagree with most of the things you just said.
Great.
Just to mimic the what people say is not really to build a model of the world at all, I don't think. You're mimicking things that have a model of the world, the people. Right. But I don't want to approach the question adversarial way. But I would question the idea that they have a world model. So a world model would enable you to predict what would happen.
Right.
They have the ability to predict what a person would say. They don't have the ability to predict what will happen. What we want, I think, to quote Alan Turing, what we want is a machine that can learn from experience.
Right.
Where experience is the things that actually happen in your life. You do things, you see what happens, and that's what you learn from. The large language models learn from something else. They learn from, here's a situation, and here's what a person did. And implicitly, the suggestion is you should do what the person did.
So you listened to the whole podcast. I thought a good place to start, since the bitter lesson is on people's minds, and I thought this conversation was super interesting. And while I think Sutton took a lot of heat for sort of maybe being stuck in a particular worldview, I thought he was pretty consistent. But yeah, I don't know. You're the one who introduced me to the bitter lesson first time. Give me the rundown on the bitter lesson.
Yeah. So let's actually look at the essay itself. This is the essay, came out in 2019. The key point is this. The biggest lesson that we read from 70 years of AI research is that general methods that leverage computation ultimately are the most effective and by a large margin. So what does that mean? So here's kind of a practical, this is kind of the practical point I think is really interesting here. So in the short term, when we're trying to solve problems, we often tell the algorithm how to solve the problem. We give it a shortcut. And usually this is based on some kind of human knowledge of the domain. There's a lot of examples of this. Like in vision, a lot of the early methods were different things like edge detectors. So basically a bunch of, AI researchers got together, they focused on vision. They designed very particular kind of feature extractors based on things like edges. And they kind of told models how to solve problems based upon this domain knowledge. And so this particular combination of edges is going to be a cat versus a dog. The observation, though, is if you just give models enough computation, you can strip out these human biases, and often just more simpler algorithms with more computation outperform. And the idea here is that often our human biases hobble the model and prevent it from solving the problem in a better way, provided sufficient computation. So that's really the point of the bitter lesson. And we've seen this across many different areas of AI research. And the essay goes through a bunch of examples. We saw it in chess. We saw it with Go. Vision's a great example of this. So it's been seen over and over and over. The argument is that LLMs are bitter lesson pilled because we know from scaling laws very clearly, as you add compute, parameters, and data, number goes up, number being performance. So the implicit assumption within the community is that, well, LLMs are very bitter lesson pilled. And what's interesting about this interview is Sutton is saying, no, they're not. And we could talk about that and why they're not. But I want to pause there.
Yeah, well, I think we should talk about why they're not, because I thought, I had read this essay, I guess, and I had sort of understood it, and it's sort of, I've read it a couple times and really tried to internalize it. I've thought about it a lot, and I think we should talk about the sort of implications of this. AI engineering in a lot of ways is like sort of the antithesis of the bitter lesson, right? Like it's kind of, we are layering things on top, and I think what I found particularly interesting about the conversation was it just kind of like, Sutton is just a real purist, that the only way to really build towards intelligence is to let the intelligence emerge and to guide it as little as possible. And that ultimately methods that guide that intelligence are going to be beat out in the long run by methods that don't, right? He uses the AlphaGo versus AlphaZero example, right? Where AlphaGo was trained on games and AlphaZero was trained on nothing and ultimately built a far more intelligent. My other big takeaway from the conversation, which I think really relates back to the kind of forward deployed theme, is just I was reminded of how much academia still is in this world, right? And that's your world that you came from. You know it a lot better than I do, but ultimately, I think this was, hour-long conversation about the definition of intelligence. And while I appreciate that there are people out there thinking about this, and they've obviously thought about it much more than I do, this has very little impact on my day-to-day life building things with these models. Because, my challenge is essentially how to take the tools that have been made available to me by brilliant people like Richard Sutton, and to figure out where their edges are and to take the most advantage of them. And, the sort of theoretical limits of what intelligence is and the AGI conversation don't really affect me on a day-to-day basis. So that was kind of my big takeaway and reminder in this whole thing.
Yeah. Well, that's right. What's interesting is it's kind of implicitly been assumed that LLMs are bitter lesson pilled, and we know scaling laws. The scaling laws work is obviously extremely famous. So Jared Kaplan was at OpenAI, Dario Modi, famously now co-founders of Anthropic. So this idea of bitter lesson and scaling is kind of very fundamental to this current kind of wave of LLMs, and we've seen scaling across many orders of magnitude. So it's surprising then to see the author of the bitter lesson essay itself say LLMs are not bitter lesson pilled. So why might that be? He makes a very particular point, which is actually interesting, and this has been echoed in a really good interview, which I'll share in the show notes, with Sholto Douglas, a researcher at Anthropic. And what he argues is, and this is where it's quite reasonable, LLMs are trained on a bunch of human data, which is to say the internet. And more than that, the pipelines that train these models are very complex, handcrafted objects. And even more than that, they use reinforcement fine-tuning, which use environments that are defined by humans with reward models or different rewards that are designed by. So there actually is a large amount of what you might call human bias in the training of these large language models. So this was a treat from Andrej Karpathy that kind of addressed this. And what he mentioned is Sutton is kind of a purist or like a classicist. And kind of what he talks about evokes the original concept of Turing's child machine, a system capable of learning through experience, dynamically interacting with the environment, without this big, nasty pre-training prior. Now, the interesting point that I believe Sutton makes, and I think you were interested in as well, is kind of this idea of animals. And, oh, well, when animals learn from their environment directly. But a pretty fair counter I've heard is that animals have a genome. A genome is effectively, like a prior, and it's carved out through millennia of evolution. And you can think about pre-training as a way of giving these models a very strong prior for tasks that are relevant to humans. And it's a very good prior for RL. And so, in any case, it is true that what Sutton's arguing is that these models are trained using a pipeline that has lots of human bias in terms of the data itself, in terms of the decisions in the pipeline itself, in terms of the rewards, in terms of the RL environments. But it's still important and useful to give these models a prior, which effectively we're doing through pre-training is one. And two, the point made by Sholto at Anthropic is we don't have evidence yet that we're seeing a slowdown, which is to say, for every benchmark we set up across different tasks where we apply, for example, reinforcement fine-tuning, we're seeing models blow through the benchmark. So it's not obvious that we're hobbled by the fact that we're using this pre-training prior that contains lots of human bias. But I think any researcher at Anthropic will acknowledge that what Sutton is arguing is in principle great. It's kind of what Karpathy talks about here. It's kind of a platonic ideal for how you could actually think about building these models. But in practice today, pre-training is a very useful prior. And we don't really see evidence of things slowing if you look at the benchmarks. That's kind of the take that I kind of like from all of
I
this.
think, then I really think I want to move to this, your application of the bitter lesson to some of the work that you've been doing. And I've got some thoughts on it too. But my last piece on this is just, fundamentally my takeaway from it. And to that point is just like, obviously Andre Karpathy and Richard Sutton know a lot more about AI and large language models than I do. My takeaway from that conversation was just like, he is talking about in another video, which I'll put in the show notes, lecture that Sutton gave. And, he talks about it as tool AI versus agent AI. And that's the distinction he draws. And, I think he's particularly interested in sort of how you build agent AI, which I think most people call AGI. And I think he says that what we have right now as tool AI, which he would include large language models, are amazing and super useful. And, again, I think that's our focus on a day-to-day basis as builders is on, tool AI. It's like, how do we get the most out of these amazing things that we now have to play with in our tool chest? But, his point of view, and again, he knows a lot more about it than I do, and I certainly wouldn't argue, is that like, it's not the route to agent AI. And, there's people who agree with him who are also very smart. And I have no idea. And I guess my bigger thing is just like, it has no real effect on me on a day-to-day basis. Like AGI, other than being a sort of like 3 letters, is, not something that has any real bearing on my life. But, I think switching gears to the ideas from Bitter Lesson, I thought it'd be cool for you to talk a little about this piece you wrote back in July, which is just about sort of how you thought about applying how you sort of took some of those lessons into your own work. And why don't you take us through this?
Yeah. Here's the thing that's tricky about the bitter lesson. The bitter lesson argues that over time, whatever human biases that you inject in your application to solve a problem today are not useful in the longer term. As, for example, as computation grows. Now, how you map that to the world of AI engineering, which is actually very relevant for your work and my work day to day, and you've had this experience, I bet. I'm building an application. I'm working with a particular model. The model's hobbled in some particular ways. I define some scaffolding or some logic to work around those problems. New model comes out. My scaffolding is no longer relevant, and it might even hurt performance. That is a small-scale illustration of this bitter lesson concept, that we're building on top of a thing, models that are getting exponentially better. Just like compute is getting...
I think the canonical example of this for me was just earlier this year, right? Where all of everything I had built for the previous 2 years, which basically sort of, required lots of control flow and scaffolding all of a sudden. And, I still feel like I'm discovering sort of which pieces of this are still required and which aren't. But all of a sudden, with these new reasoning models and their ability to call tools in a much more deterministic fashion, a much more predictable fashion, everything, sort of my entire approach to building has changed.
100%. No, it's classic. And there's a great talk from Hyungwon Chung, OpenAI at the time. Now he's at Meta, where he argues that the way to think about this, both in research and I kind of map it to AI engineering, is that sure, add structure, which in your case could be like scaffolding, shortcuts, bias, hacks, whatever, needed for the given level of, in our case, model capability. But here's the key point: remove later to ensure they don't become bottlenecks. And this whole essay talks about my experience with that. I think the key thing that he argues, which often we miss, is make sure you rip it out later, because it can become debt or hobble the performance of your application. And this is like a little diagram that I show just talking about some of my own work, where LM capability gets better and better and better over time. For a while, and this, I talk about my work on OpenDeep Research, a fun open source research agent. But for a while, I was using like a scaffolded workflow. I was not using an agent, and it was better than my agent prototype for a while. But then, kind of like you're saying, tool calling, or in this case, models plus tool calling, got much, much better. And suddenly, the agent outperformed the structured workflow by a lot. And these things can flip pretty quickly with different model generations. And you have to be very wary of this. And the essay talks about how I kind of didn't revisit my assumptions very quickly as models got better. And I basically found that I wasn't using tool calling, and suddenly I was blocked out from using MCP. And over time, I had to rip out my entire application and rebuild it. Now, a funny point here is Boris, the code lead of Claude Code, has actually talked about this as well. And someone asked him, with Claude Code, how much is it the model in terms of performance, like model versus harness, like agent harness being the scaffolding around it? And he said it's currently 70-30, 70% model, 30% like the agent harness, the context engineering that they do with Claude Code. And the follow-up question was, oh, well, as models get better, does that mean you're going to rip out all the scaffolding work is going to be, useless? And he said, yeah, that's it. You have to just be constantly revisiting your as models get better. And I think that's just the reality of building on top of this new and rapidly improving primitive, which are LLMs. And so,
yeah, totally. And
yeah,
I think, a couple of thoughts on this. Like another sort of just very simple canonical example, right, is that, we all read the Google chain of thought paper, and we started layering chain of thought prompts into all our work, right? Because they were performing way better than non-chain of thought prompts. And then reasoning models came along, and if you didn't update your prompts, all of a sudden reasoning models with chain of thought prompts just didn't work. Because you didn't want it to, it already had the reasoning built in. And so if you tried to add the reasoning to the reasoning, it sort of broke everything. And if you didn't go back and rip out those old prompts and just sort of remove them. Now, in the long run, what I've seen, and I'm sure you've seen, is like, I'm bulking up my prompts a ton. Like I've now with Sonnet 4.5, like I can throw gigantic prompts in there, and it sort of is incredibly capable. And we'll talk a little about Claude Code and some of what I've been doing in there. But yeah, that one is sort of the simplest. The other side of this that I think is funny, and I think you and I have debated this in the past, is again, this is where the bitter lesson is also. I like that quote a lot that you gave from the guy who's at OpenAI and now at Meta. You can't be stuck on any of these things, right? Like we're all figuring out like the edges of these models are not, and we're all working in the edges. And so when you find a place to build a tool or a trick or a scaffolding, or you don't need it, you just do whatever you have to do to get the most out of it. And we're all sort of figuring that out as we go. And then I love your point that you just have to be willing to pull it out. The only other thing I'd add here is just like Charles from my team, this great piece about thinking ahead. And his point was sort of, when you're building, you've got to kind of build things that don't work perfectly. Like if you build to perfection and you sort of like totally optimize the current model, then your ability to actually get advantage of future model development is going to be so much more limited than if you build to like 90%, where you get it really, really good, but it still has some fuzziness, and there's still some places where it doesn't do all the things. And you've got to kind of build that these models are just going to keep getting better. I also think of this as like, It's like my hungry hippos theory of AI engineering, which is like, there's $800 billion or $1 trillion, however many trillions of dollars of capex that's going to go into training new models over the next 12 months. And you just like, we all just want to be like, we want to have our like alligator arms, and we just want to capture as much of the value of those models as possible. And to do that, I think you kind of have to just be like, okay, I can't ever try to optimize anything I'm building to perfection,
Yeah.
because if I optimize it to perfection,
Yeah.
then my ability to plug in a new model is just going to be so limited
Yeah.
that actually the long-term value of this application is going to go down and not up. And I think, one of the core kind of changes that's happened in software development is the idea that you can now build things that gain value over time instead of losing them.
Yeah.
And like, that's a mind-blowing concept.
Well, it's funny. There's a lot of threads on this where actually there's a good talk, I'll link in the show notes, from Jared Kaplan, the co-founder of Anthropic. He actually argues that a sane strategy is to build things that explicitly don't quite work yet. And actually, Cursor's a good example of this. Cursor didn't really work until 3.5. And suddenly it had the unlock because the model capability caught up with the product kind of surface and experience. It's not a bad take. And the converse can be true as well. If you build for the current capability without kind of a nice forward look as to how the product evolves, then a new generation model will just completely eat your product. We've seen a lot of those examples too. So it is a very interesting time to build. It's tricky. You have to be very nimble. You have to be willing to kind of continually re-implement your application logic over time and rethink your product as models get better.
You can't be precious with your code.
No.
Which,
No.
like, given that we're all using these tools to coding anyway, we should be less precious to begin with.
Yeah.
Let's talk about Claude Code for a sec. I've been fully obsessed. I did this interview where I talked about how I've been using Claude Code with Obsidian. I know you use Obsidian.
Yeah.
Obsidian's a pretty simple tool for just writing notes, but the big idea, which it's funny to call it a big idea, is that they store them as markdown files on your local computer. And, one day, actually, I think in a group chat we were in, somebody was like, have you tried opening your Obsidian in Cursor? And I hadn't thought of that, and I opened it in Cursor, and I didn't really love that, but then I opened it in Claude Code, and I just sort of completely got lost, and it's become a kind of primary way that I use my notes and I write notes, and that I just kind of think, and I call it my Obsidian CLI. So like, even getting ready for this podcast, I had it pull together a bunch of ideas. I gave it a kind of rough outline. Can you pull me my notes for the forward deployed? So, at its most basic, before I get into any of the kind of other pieces that I have in place, this is, again, it's just sitting over a folder in my computer. The folder has all these markdown files and is able to just kind of interact with them. And I wrote a piece, which I'll share, that kind of made it around Hacker News last week or the week before. But, my kind of big aha is that, like, the real unlock of Claude Code is a combination of file system access, right? And the file system access is so remarkable because not only can it read, but also file system access solves for like the biggest limitations we have with these models, right? Which is that they're stateless, and that that we don't have memory. So all of a sudden, your file system access, you can write to file, you can keep state, you can keep memory, you can do whatever you want. That it solves such a huge hurdle. If you think about the work that you do in building applications using these models, like, so much of it is working around that. And it's like, all of a sudden, it doesn't exist anymore in Claude Code, because you're like, just write it out to a file and then read the file again. And then the other big unlock for me, and this I didn't figure out until I was reading the interview that Boris did for the Pragmatic Engineer, it was just the bash commands. If you go back and you read the Unix philosophy, like, the whole idea of it is build these tiny, simple tools that do one thing incredibly well, but they're composable and you can chain them together, right? And what you see, and I think what makes Claude Code work so amazing, and I think my big lesson that I've tried to take back to building everything is, like, the perfect set of tools are Unix tools, right? Because it's like, you've got grep. Grep just does this one thing,
Yeah.
right? And then you pipe grep to something else.
Yeah.
And I think, when one of the mistakes I see people make when they're adding tool calling is they try to build these massively complicated tools. And it's like, no, you need lots of simple tools, right?
Yeah.
And those simple tools, and then you let the AI is sort of doing the piping. And there's a whole other side, which either we can talk about later today or another future episode, which is I'm sort of very excited about the day when some model figures out how to actually pipe without requiring moving things through context windows, because that's sort of the big dream. But what you've got here obviously is like it can very easily, so it found my forward deployed pod. It can do all these things, but where I've really kind of had fun is like I added a DAIFI command. So the DAIFI command is just a whole bunch of sort of typical AI words. And I can ask it to DAIFI the script. And, the commands, I think, have been a huge unlock. And again, have really inspired me in building lots of other things. And I think they kind of get back to the bitter lesson idea, which is commands are sort of these incredible agents, right? But they're just a prompt and a bunch of tools that the prompt has access to, right? So if you actually look at what goes into a command, it's nothing more than a markdown file with some YAML at the top. And the YAML just says, what does this command do? And it says, what tools does it have access to running without your permission? And it just follows it perfectly. Like, it's amazing how well it follows it. And again, like, if I think about so much of the work I've done over the last 3 years has been like, how do you build these control flows? And it's like, now the best control flow I've ever used is just a long prompt in Claude Code is a really, it's a pure bitter lesson idea, I think, which is just like over time, the models are going to sort of so much other work that we do because they're just going to keep getting smarter and keep getting better. So this thing is just running this DAIFI command. As it's done running, I can actually show you what the command looks like, and I can share the whole. I'll share the whole command. I've got a separate repo here. So coming out of the podcast, enough people were really excited about it that I just took a bunch of the tools I have in my own CLI and I put together this repo, and the repo has all that stuff in there. So here's the DAIFI command.
Yeah.
And again, you can see
That's
like
cool.
the YAML at the top, it's just some YAML. It says that this has access to read, write, and edit. And then, it's just text, right? Like we're just basic instructions. And it's just pretty extraordinary in the ways that it's able to follow it. And, again, because it has the bash commands and everything else, it's also able to then, create files, add it to memory, move that around, use it in the future. And I feel like I'm still just scratching the surface with Claude Code, but I think I have moved almost everything over to this. Everything I do on my computer now, I have manages all my computer. I have a computer CLI that like does all my configuration on my computer. I use it across, obviously all my notes. I even now have bought a server for the basement, and I'm running Tailscale on that server so that I can be on my phone using an app called Termius, and I can just like take notes and interact with Claude Code from my phone because I just have become so reliant on it. And, I think, to me, it represents a really interesting sort of departure from a lot of the other conversations that are happening around agents because, I know for me, and I'm assuming for you, it's like a lot of it has been this work around scaffolding and a work around control flows and and it's like, it just feels like we're getting to this place where you can get it to do so much more. And then, the last piece I just want to say here, that I haven't even dug into this. It was yesterday, but I don't know if you saw that they launched plugins. And so I think if I'm reading this correctly, basically I can take my Claude Cydian setup here, which is a bunch of commands and a bunch of tools, MCPs, and I can just package it as a plugin. They're going to have a marketplace. So I'm incredibly excited about this. My next big project actually is to start playing. They have an SDK.
Yep.
So you can just run this as a standalone agent. I don't know if you've played with that much, but
Right.
I'm so bullish on Claude Code.
Yeah.
I think it's by far the best tool out there. And I think that coding in the end is going to be maybe just, a small piece of how people use it.
A couple things we can say about this, which are really interesting. So this was a test I did. This was back in April. I got really into Claude Code kind of back in March, April. I did this internal benchmark where I compared Claude Code to Cursor and a few different ways to access context on a bunch of LangGraph coding questions. Okay. And the point is that Claude Code outperformed Cursor in my little eval. And the best way to access context, it turns out, I tested a few different approaches. I tested basically just stuffing all docs directly into the context itself. I tested using a very simple kind of lm.txt file, which is basically just like a guide with a simple URL loader tool. And I tested a vector store. And I found that Claude Code, just with a very simple kind of file loading, and in this case, I provided it with this lms.txt to kind of help it choose which files to load, was the best. And that's what got me turned on to Claude Code initially. But I think what's interesting about Claude Code is a few different things. One, it's one of the first pure agent products that's been a smash hit. I think OpenDeep Research was one, it was one of the first pure agent products that became a big hit. I think Deep Research from OpenAI and Gemini was also one, but this was really presented in a very different way. It was presented through the terminal, and typically when you think about code, you think about an IDE, and a lot of IDEs, like Cursor as an example, use some kind of indexing of your code under the hood. So use a vector store, and they have embeddings, and there's actually a good talk I'll link in the show notes from Lee Robinson just yesterday or this week at OpenAI Demo Day. They talk about it. Claude Code is very simple. Like you said, it's using glob and grep. Very simple bash tools to read files. And I think the interesting point on Claude Code is that what they found is that if you just apply reinforcement fine-tuning with a simple set of file search tools, glob grep, it can be extremely strong. The catch is that it doesn't use indexing. So basically to find something, it has to use, like you can see, even when you showed your kind of Claude Code traces, it's literally calling grep with some search term. Like you ask about your podcast name, it's just basically calling, it's calling grep with like, okay, find files that have this. It's just hunting around like a human would, but it's really good at it. So it's a little bit less efficient in some ways than if I had an index and I indexed all my files, just like Cursor does, but it's simple. And Boris from Claude Code talks about this a lot, that oftentimes more general things around an exponentially improving model win. And so he talks about that in light of that's why they chose to surface it through the terminal. This actually gets a little bit to the point about kind of AI fitting into all the nooks and crannies, like the English muffin of the org. And Boris talks about this explicitly. He mentions the fact that they're trying to build something that will work for every developer within Anthropic. Developers use VS Code, they use Vim, they use Emacs, they use Zed. What's the common denominator? Terminal. So you can just slip the AI into the terminal, that's Claude Code, and it can then fit into every workflow. And it's like the nooks and crannies thing. It just works. So many people now have kind of ramped up on terminal, including non-technical users, because look, Claude Code is just a general purpose agent. Of course, it can do code, but like we saw here, it can also do great things. It can do markdown. It can write.
Writing, yeah.
all
I mean,
that.
I think the other lesson I take away from this, we see it in the coding, right? Like these coding tools are better at more popular languages, right? The coding tools perform best in JavaScript, TypeScript, and Python, right? They perform better in sort of heavily used languages than they do in less used, less documented languages. That makes sense, right? The training corpus has tons and tons of that data in it. And so obviously it's learned to write more JavaScript because there's more JavaScript in the world than anything else, right? And it's learned to write more Python than it's learned to write Zig. But the other thing, I think part of the reason that Claude Code works so well versus some of these more advanced techniques is just, these Unix tools are incredibly well documented, right?
Yeah.
Like they're very well represented
Yeah.
in the corpus. And so it makes sense that, again, and I think the general principle here that I've taken away and applied in lots of other places is like, the Unix philosophy, small tools, do small things, chain them together, make them composable. It's also like name them well, right? Like
Yes.
naming tools is such a critical thing. And it's like, obviously grep is not a great name for a tool, but it's well documented enough on the internet and in the training corpus that it counts as a great name. And so I think there's a lot of these pieces that, reading the pragmatic engineer interview, like obviously this was not all planned. I think most of these great tools that come out of AI, ChatGPT was not all planned.
Yeah.
Like they're very emergent. People are trying things out. That's the fun of working in this field, is that like we're all getting to live on the edge and try things maybe for the first time. But I think, finding places where you lean into really well places where you don't need to layer on a whole bunch of additional instructions for how to use the vector store effectively, because it's already been trained on 10 million tokens on how to use grep.
Yeah. I will make a small note, though, that actually one of the major advantages that Anthropic has in releasing a coding agent product like this versus everyone else, effectively, is that they can apply reinforcement fine-tuning with their model within their harness, given the set of tools, extensively. And so this makes it extremely good within its harness at things like what they call agentic search, which is basically iterative calls to glob or grep to hunt around and find things. So, of course, the pre-trained model or the model that they're using, whatever it's Claude 4 or 5, some fine-tuned version of 4 or 5, obviously is very strong. But then this reinforcement fine-tuning within the Claude Code harness that they're applying on top can make it extremely good. And that's why you can see it's so effective, which we all can't do. I mean, I built a lot of agents on top of whatever 4 or 5, and actually for my case more like 3.7, 3.5. But of course, I don't have the ability to actually perform reinforcement fine-tuning on my harness to like make it extremely good at very narrow tasks. And so I think it is true that the reinforcement fine-tuning they can apply has made it exceptionally strong at this agentic search capability. And so it's obviously a major advantage that they have that other coding agent offerings that build on top of just the API don't have.
I keep seeing people talk about DSPY. Have you dug in on that at all?
So one of the best write-ups on DSPY is actually from Drew Brunig. So Drew's a really sharp guy. He and I did a workshop together on context engineering. I got to know him that way. Great writer, great communicator. He's big into DSPY. I actually personally have not used it very much, but this is probably the write-up that I would direct people to. Maybe a simple way to think about DSPY is basically that DSPY is a simple way to have like a system kind of write its own prompts. And so this is like the hello world for DSPY. You connect to an LLM to find your model and a signature and just kind of run your task. DSPY creates a prompt from your signature given the specified module. And you can kind of walk through the examples of how it kind of takes care of that prompt writing and engineering itself. And as many different modules, you can kind of see they are modular. You can swap them in and out. There's this chain of thought. There's predict.
And it's basically optimizing. It's able to optimize its own prompts, right? That's sort of
that's the key point. That's right.
Yeah. I'm just curious. I've been finding this in my own. I've been using GPT-5 Pro as a backstop on hard problems a lot. Have you like been playing much with 5 Pro?
Not as much myself. People love 5. I'm still largely an Anthropic guy. I'm mostly using Claude.
I've been finding that when I run into a particularly sticky problem, whether it's working on writing something and I can't figure out a paragraph, or I'm working on some code, I'll pull it out, bring it over to 5 Pro, and it one-shots it.
Really?
And I've got to give it like a constrained problem. Like I don't love giving it an open-ended problem, have it designed from the beginning. But when I run into a roadblock, I really find that it just sort of crushes it. And like you give it something that you haven't quite been able to figure out. I was trying to crack actually this very annoying, I was trying to do Claude style paste blocks in input field. And I just couldn't get the interaction quite right. I was trying all these different pieces. And I basically brought everything I had tried and all the code over to GPT-5 Pro, and it just one-shotted. And it figured out that I had missed this particular paste hook handler or something, that it just sort of solved the problem. It was awesome. Last one for you. This is just a sort of fun one. This is a conversation we've been having on Slack lately, and I wanted to ask you is do you think managers or ICs are better at getting value out of AI?
Or to generalize, I think, frankly, I talked to a lot of people who were, many of them former managers. I was a manager for many years. A lot of people don't want to be managers right now because they're worried that they want to stay very, very close to the metal because so many things are happening with AI. That's actually why I've been pretty happy not to be the manager within LangChain for the last 2 years, even though I was a manager for many years before that, because so many things are happening. You want to have that, what's that German word? The fingertip feeling.
Fingerspitzengefühl. Yeah, I agree with what you're saying completely. And I try to live as much of my life that way as possible. I actually mean something slightly different, which is I am wondering if those people who have managed people find it easier to
see.
direct direct models to help them because they're used to delegating tasks. This has just been an idea floating around in my head. I was curious if you had any thoughts or if you've seen anything.
That's interesting. I think it's actually somewhat offset by the fact that ICs have more urgent pressing needs and they have more urgent kind of pressing tasks that need to be automated. And so my sense is that ICs are adopting the technology extremely quickly because they see the opportunity to automate parts of the work that they want to do. So they have a stronger kind of immediate incentive to use AI. And that's kind of that the fingertip feeling that you want to make sure you're close to the metal. You have tasks that require AI and that you're ramping up on the technology, you're using it readily. It's a good point though that managers may be more comfortable with kind of delegation. Maybe.
I think the sweet spot, for what it's worth,
Mm.
and maybe I'm just like trying to be hopeful about myself,
Right,
and
right.
but I think you're in the same boat. Is
Right.
like having had experience as a manager, understanding sort of how to split things up and delegate, and now being back in IC roles, I feel like I have the best of both worlds. I have a lot of comfort in sort of delegating out tasks,
Yeah.
but I am very close to the metal, and I do have those pressing. I couldn't agree more. I think like to me, one of the sort of core tenets of forward deployed is this idea that like we're going to shrink the gap between problems and the people who solve problems, right?
Mm.
Like we, for a very long time, have had lots of people who had to sit in the middle of a problem, like a person within an organization who has a specific problem, got translated through a product manager or a project manager, and then somebody else and somebody else that finally made it to the engineer. And I think like we're just shrinking the gap. And that's what's exciting and interesting about the moment. I know you got to go run some errands, do some things. So this was
That was
fun.
great.
Let's keep doing it.
We'll do it.